kidding. Hold up, you got me woke up. The way you roll that, sticky like okra. Just let me coach ya, show you about my culture. It's a late night show like Conan. Bitch, the party ain't over.
Is this working? I think it's working. All right. This is the pilot video here. Andy's bio videos. Andy's super cool bio videos. The first one. This is about the structure of a leaf. It's for the photosynthesis unit. It's to prove for this assignment that I actually understand photosynthesis, which, by the way, I do not. Okay, so here we have a leaf. As you can see, these are supposed to be the leafy things. This is the inside of the leaf. Now let's talk about what's on the leaf. You see, here we got a waxy cuticle on this line part here. You know, that's to prevent desiccation. Now you may be asking, Andy, what is desiccation? I'm pretty sure that's loss of water. Is that loss of water, J-Ben? Yeah. So it's waxy, so water doesn't leave, because the plant wants all of that water. That's the whole point of your life. You only want water. All right. Moving on. Look at the mesophyll here. You see, on the leafy surface, underneath it, you got whole rows of cells here called the mesophyll, and that's why they're all lined up and squarish. And you see on the top here, they're called palisade parenchymal. And much like a palisade, they're really solid stuff and exist only for structure and don't do much else other than be structured. There also happens to be a lot of plasmodesmata here for movement of stuff. I mean, honestly, I don't know how many questions you're going to ask in the test. Let's be real. That seems like such a small detail. Down here we have the spongy parenchymal of the cells. You see, this is where the real magic happens. Nobody cares about what happens on top. This is where it all happens. You see, these spongy parenchymal cells are good for gas transfers, and they also prevent water loss. Yeah, prevent water loss, and they allow for gas exchange because they're all spongy and stuff, and not a palisade, which if you Google palisade, is not something that would allow gas exchange.
No, I'm doing it right now.
Right, Kyle?
Spongy's in the middle. Palisade's on the outside.
You can stay here.
This is the bottom spongy.
No, middle spongy.
Hey, wait, J-Bay, is the middle spongy as well?
Spongy.
What about, is spongy also the bottom one or no?
Palisade,
Palisade.
caramel are both
This is totally wrong. This is totally wrong, man. My notes are wrong.
Just extend the arrow to the
I'll
middle.
extend the arrow. Okay.
Palisades are both the top and bottom.
Okay. J-Bay students, I lied to you. I've lied to you.
For the past 10
This
minutes.
is also palisade. These are spongy for gas exchange and stuff like that. Scratch that. I don't know crap about bio.
You do too. Stop it.
You should show this video. Alright, so now we know what these cells are. Now we get it. Let's talk about these little circles I drew here, They're like, Andy, what are these circles? And I'm like, I can't really tell. Only I can tell. You know why? Because I labeled it. It's right here. This label here is stomata. Stomata. You see, stomata, what they do is,
That's good. Where's your connections to
they
solids?
prevent, water loss, and they allow for gas exchange. This is how
I think that it
your
would
water,
help.
this is how your gases are getting in there, and this is how water is not, just diffusing out of there. Because, look, you got more on the bottom, because you want to prevent that water loss, because gravity exists. That's right. You're going to be like, Andy, I'm a hardcore Catholic. Gravity's not real. And I'll be like, no. You're wrong. Gravity is real. I don't hate Catholics. Catholics are really cool. I have a best friend. He's Catholic. I'm not Catholic myself, but Catholics are cool people, and they do believe in gravity. Okay, so you have the stomata. These are good for gas exchange. And as you can see from these nice little diagrams I drew here, I can't. Yeah, you can tell. You see, we have a little open stomata, and we have a little closed stomata. When you want to allow gases to go in, the stomata is all open and stuff. And when you don't want stuff to get out, it's all closed and stuff. It's really nice. It's like a door. You close it when you don't want stuff to leave. Or when you want, then you open it when you want to leave. You see? It works that way. It just does. So, when we're looking at how plants, take our CO2 and then give us oxygen. We got a little stomata right here. We got some CO2. It's going in the stomata. Hits one of those spongy parenchymal cells. Does that whole whatever cells do with it, which will be covered later. And then we get O2, and then it goes back out this stomata. And then there we go. Then we can breathe and live. If any of you guys have seen The Martian, this is not what happens in the movie. He has a machine called the oxygenator, and it's really like it makes the whole thing easy for him, in my opinion. Just to be fair. Anyway, this is a cross section of the leaf video. Be sure to like and subscribe, and ask J-Bay to keep showing my videos, which I will continue to make as long as J-Bay allows me to.